Hi my dear students, myself Kedarnath. Welcome to my channel Make Mathematics Simple. So today I am going to explain matrices and determinants, previous year KCET and COMED problems and some of the problems from JW also. Okay, so be careful. This is the easiest topic. This is the most easiest topic. You can score easily 7 marks in KCET because in every year on and average 7 problems are asking in from the topic matrices and determinants. So if you watch this video till the end, then 7 marks in your pocket. So already I did differentiation also. Once you go through that video also, because from differentiation it is giving around 6 problems and here around 7 to 8 problems. So if you watch these two videos, so 6 plus 8 around 14 marks in your pocket only. Okay, so now look at this. If A is a square matrix of order n, if A is a square matrix of order n, then determinant of Ka formula is what? K power n into det A. Determinant of K into A is equal to what? K power n into det A. So where K is a constant. So whatever I have written here, the problems, almost each problem asked 2 times. Every problem, whatever I have written here, almost every problem asked 2 times. So particularly this problem, third problem, it is asked 3 times. Okay, so now look at this first problem. If A is a square matrix of order 3, then determinant of 5A. So just using above formula only. Na? So here order n is how much? 3. Order n is how much? 3. So then using that formula, what you will get? K power n, that is 5 power 3 into det A. What is 5 power 3? 125 into det A. Over. Okay. Next here, second problem, A is a square matrix of order 3 by 3. Then what is det Ka? So direct formula only. Na? So again here n value is how much? 3. So what is the answer? K power n. What is n value here? 3. So K cube into det A over. Next, A is a 3 by 3 square matrix. Then det of 3A. A is a 3 by 3 square matrix. Then what is det of 3A? So just a direct formula only. Na? Here K value how much? 3. N value is also how much? 3. K power n means 3 power 3 into det A. So that is 27 into det A over. Next, A is a square matrix of order 2 by 2 and det A value 10. Then what is the determinant of 9A? So first use det of Ka formula and here n value is how much? 2. So det of 9A is equal to what you will get? 9 square into det A. 9 square is how much? 81 into det A. What is det A value? 10. So 81 into 10 is how much? 810 over. So hardly how much time it has taken? 5 seconds. Okay. Now look at this problem. Determinant of A power m is same as det A whole power m. So based upon this formula, this problem asked 3 times. The same problem, numbers also they are not changed. Okay. So det of A cube is equal to 27. Then what is alpha value? Don't try to calculate A cube. Don't try to calculate stupidly A cube. So use this formula. Det of A power m is equal to det A whole power m. So det of A cube is equal to what you will get? Det A whole cube. It is equal to how much? 27. Det A whole cube is 27 means det A is equal to what you will get? 3. Because 27 is nothing but 3 cube only. Na? So det A whole cube is equal to 3 cube. Then det A is equal to 3. So this is the given matrix A. What is the determinant of A? Cross multiplication only. Na? AD minus BC. Correct? So then what is determinant of A? Alpha square minus 2 into 2, 4 is equal to 3. So that means what you will get? Alpha square is equal to 3 plus 4, 7. So alpha square is 7 means alpha is equal to what you will get? Plus or minus root 7. So that was the answer. So look at the next set of problems. So just once you look at these formulas, if A is a square matrix of order n, then determinant of adjoint A is same as determinant of cofactor matrix, which is equal to det A power n minus 1. Det A power 1 less than the order of A. Okay? And determinant of A inverse is equal to 1 upon det A. Next, determinant of AB is equal to determinant of A into determinant of B. Determinant of A dash is same as determinant of A. That is, A dash is nothing but A transpose. Determinant of transpose of the matrix is same as determinant of the matrix. And A into adjoint A is equal to det A into I. Okay. Now problems based upon these formulas. So because all problems are asked minimum 2 times. Okay. So look at this first question. So here the statement is, if A is a square matrix of order 3 by 3. Okay. So short form I have written here. Here I have written in short form. If capital A is a square matrix of order 3 by 3 and det A is equal to 16, then what is the det of adjoint A? So what is the det of adjoint A formula? Det A power n minus 1. So here what is det A? 16. Power n minus 1. What is n value? 3. So power 3 minus 1. So 16 power 3 minus 1 is nothing but 16 square. So what is 16 square value? 256 over. So hardly just 5 seconds. Okay. Next. So next look at second problem. If A is a square matrix of order 3 by 3 and determinant of A is 4, then the determinant formed by replacing each of its cofactors is. That means we are replacing the elements of A by their corresponding cofactors. Then what is the determinant of that matrix? So if you replace the elements of the matrix by their cofactors, whatever obtained matrix is what? Cofactor matrix. And what they are asking? Determinant of cofactor matrix. What is the determinant of cofactor matrix? Same, det A power n minus 1. So here also same only, na, det A power n minus 1. Here det A value is how much? 4 power n minus 1. What is n value? N is nothing but order only, na. So n minus 1 is 3 minus 1. So 4 square how much? 16 over. Now look at third problem. A is a square matrix of order 3 by 3. A into adjoint A is equal to 10 into I. Then what is the determinant of adjoint A? So A into adjoint A into A equal to what? Det A into I. A into adjoint A. If it is ulta, then like adjoint A into A, that is also det A into I only. So here instead of det A, what we have? 10. So that means from this condition, what we got? Det A value. What we got? Det A value? 10. From this condition, what we got? Det A value? 10. And what we have to find? Det of adjoint A. So if they ask det of adjoint A or det of A dash, det of A transpose, and whatever det of A inverse, first you find det A. Okay. So we got det A and we have to find what? Det of adjoint A. So det of adjoint A formula is what? Det A power n minus 1. So 10 power n minus 1 means n value is how much? 3. So 10 power 2. 10 power 2 is how much? 100 over. Okay. Next, same model problem. So here what is det A? A into adjoint A is equal to what is given? 5i. So that means det A value is how much? 5. But what we have to find? Det of A inverse. So what is det of A inverse? 1 upon det A. It is the reciprocal of det A. Okay. So det A value 5 means det of A inverse, what will you get? 1 upon 5 over. See, just by looking that equation also, if you know all these formulas, just by looking that equation, just by looking that problem only, you can write the answer. Not it takes maximum how many seconds, Nana? At most 5 seconds. Even in 2 seconds also, just by looking that question only, you can tick the option also. Okay. So look at the 3 more problems on the same formula. Okay, so it is given A is a square matrix of order 3 by 3 and A into adjoint A is minus 2i. Then what is det of A into A dash? Okay, so A into adjoint A is equal to, what is the formula? Det A into I. So from that formula, so what you will get? Det A value minus 2, because instead of det A what we have here? Minus 2. So how to find det of A into A dash? So use this formula, det of AB is equal to det A into det B. So then det of A dash can be written as det A into det of A dash. So what is det of A value? Minus 2. Det A value? Minus 2. But as we know that det of A dash is same as det A. So this det of A dash is also what you will get? Minus 2. So minus 2 into minus 2 what you will get? Plus 4. Over. Hardly 5 seconds. See. Next up. If A is a 3 square matrix of order 3 by 3 and determinant of adjoint A is 25, then what is det of A inverse? Okay, so here as A is a 3 by 3 matrix and det of adjoint A formula is what? Det A power n minus 1. So that means here as n value 3, n minus 1, what you will get? 2 only. Na? So that means this det of adjoint A, this det of adjoint A is the same as det A whole square only, na? Because det A power n minus 1. Det A power n minus 1. Here n value is how much? 3. So 3 minus 1 how much? 2. So det A square value you got 25. Det A value 20. Det A whole square value 25. Det A square value is how much? 25. Then det A is equal to what you will get? Plus or minus 5. So det of A inverse. But we have to find what? Det of A inverse. But what is det of A inverse formula? 1 upon det A. As det A is equal to plus or minus 5, det of A inverse what you will get? Plus or minus 1 by 5. That is equal to plus or minus 1 by 5 value is how much? 0.2. Okay, 1 by 5 value is how much? 0.2. Because in the options it is given in the form of decimal 0.2, 0.3, 0.4, like that it is given. Okay. Next up, look at the last problem. So if A is equal to 2 by 2 matrix, B is also 2 by 2 matrix, then we have to calculate det of A into B transpose. So don't find A into B dash matrix. Just use det of AB formula is det A into det B. If it is det of ABC, det A into det B into det C. Okay. So now det of A into B dash is same as det A into det B into det of B dash or B transpose. Okay. You can read this as B transpose or B dash, no problem. Nothing but transpose of B. Okay. So that is equal to det A value. So any matrix A is given now, you can find det A value. So how to find det A? Cross multiplication only now. So 1 into 2, 2, minus 4 into 3, minus 12. So 2 minus 12 how much? Minus 10. So det A value is how much? Minus 10. Next det B value, cross multiplication only now. 2 2s are 4, minus 1 into minus 1. Minus of minus 1, how much? Plus 1. So 4 plus 1 how much? 5. This is det B value. This is det A value. This is det B value. Det of B dash. Det of B dash is same as det B only. Na? So det of B dash is also same as 5. Because det B value what we got? 5. So det of B dash is same as det B. So det of B dash value also what will get? 5. So on multiplying these what will get? 5 5s are 25. 25 10s are 250. So plus in minus into plus minus. So answer is minus 250. See then hardly how much time it is taking? So hardly 5 seconds. So every year and from matrices and determinants around 7 to 8 questions are asking. Among those minimum 4 questions are very simple. By looking those questions only you can tick the options. Okay. So look at the next problem. So here this is the question, this is the trick. Okay. So if A is equal to A0 0 0 B0 0 0 C, that means your diagonal elements are present but non-diagonal elements are 0 only. Na? So this is what kind of matrix? Diagonal matrix. So that diagonal matrix can also be represented as diag of A, B, C. So here how many elements are there? 3 elements. That means diag of A, B, C represents, it is a 3 by 3 diagonal matrix whose diagonal elements are A, B and C. That is the meaning of this. Then determinant of A is equal to just product of diagonal elements. A into B into C. And A inverse, as A, if A is a diagonal matrix, then A inverse is also diagonal matrix. And how you can find those diagonal elements in A inverse? Just make it reciprocal. Here A, B, C are there. No? What are the reciprocals of A, B, C? 1 by A, 1 by B, 1 by C. Then A inverse is also diagonal matrix, and the diagonal elements are 1 by A, 1 by B, 1 by C. For diagonal matrix, adjoint A is same as cofactor matrix, because diagonal matrix is also symmetric matrix. Okay, so adjoint A is same as cofactor matrix, and this is the cofactor matrix. Here what are the diagonal elements? A, B and C. Correct? And here what is the first diagonal element? A. Okay, what is the first diagonal element? A. Then in adjoint A, first element is product of these two elements, that is B into C. Second diagonal element is here B, and here second diagonal element in adjoint A is product of these remaining two diagonal elements AC. Similarly, here third diagonal element is what? C in A, and in adjoint A, then in adjoint A, that third diagonal element is a product of remaining two diagonal elements, that is A into B, AB. Okay, so anyway here they are asking only question is what? A inverse. So what is the A inverse? Tell me Anna. So what you will get here? Here diagonal elements are what? 2, 3, 4. Then in A inverse what you will get? Their reciprocals. Correct? As A is a diagonal matrix, A inverse is also diagonal matrix. So what are the diagonal elements? Reciprocals of 2, 3, 4. So reciprocal of 2 is what? 1 by 2. Reciprocal of 3 is what? 1 by 3. Reciprocal of 4 is what? 1 by 4. And remaining non-diagonal elements are equal to what? 0. See how much time it takes. Just by reading the question, by looking the options, you can take the answer only. Okay. Suppose if they have a 2 by 2 matrix, say A is equal to 2, 0, 0, 3. Then what is A inverse? Tell me Anna, A inverse what you will get? Here what are the diagonal elements? 2, 3. Correct? So reciprocals what you will get? 1 by 2, 1 by 3. Remaining non-diagonal elements are zeros. Non-diagonal elements are zeros. That is the A inverse. Okay? So suppose in this case, in first case, what is det A? In first case. So just product of diagonal elements. 2 into 3 into 4. 2 into 3 into 4 is how much? 24. And in this case, what is det A? 2 into 3, 6. Over. So look at the next set of problems. If A is a square matrix of order n by n, then the square matrix capital A can be expressed as what? A sum of symmetric and skew symmetric matrix uniquely. Every square matrix of order n can be represented uniquely as a sum of symmetric and skew symmetric matrix. Correct? So if given matrix is A, then what is the symmetric part of A? Half into A plus A dash. What is A dash? A transpose. And what is the skew symmetric part of the given matrix? Half into A minus A dash. Okay. So what is the symmetric part? Half into given matrix plus its transpose. What is the skew symmetric part? Half into given matrix minus its transpose. In symmetric, plus transpose. In skew symmetric, minus transpose. Just remember that. Okay. Now look at this problem. The symmetric part of the matrix. So that means if you take this matrix as A, then symmetric part of A is what? Half into A plus A dash. And hurry-burriedly don't try to calculate A dash and don't try to find half into A plus A dash. See, sometimes by looking the options only we can take the options. Okay. Remember, in skew symmetric matrix, we know that skew symmetric matrix diagonal elements are zeros. Okay. Now, if you observe, this square matrix can be represented as a sum of symmetric and skew symmetric. Anyway, in this skew symmetric part, diagonal elements are what? Zeros. But sum of these two matrices must be what? A. That means the diagonal elements in the symmetric part of A is the same as diagonal elements of given matrix. Correct? Because here in this symmetric part, diagonal elements are zeros. So compulsorily diagonal elements in A plus half into A plus A dash should be same as diagonal elements in A. Correct? So here in the given matrix, what are the diagonal elements? 1, 8, 7. 1, 8, 7. Look at the options where 1, 8, 7 is appear. Diagonal elements are stay. You concentrate only diagonal elements. Here 187 is not there, so answer is wrong. Here 187 is not there, this is also wrong. Here 187 is there, here also 187 is there. So among these two options only one option is correct. And also as they are asking symmetric part of the matrix, that matrix also must be symmetric matrix only. Okay, symmetric part of the capital A is nothing but symmetric matrix only. That should be symmetric matrix only. Okay, so if you observe, first option is not a symmetric matrix, because if it is a symmetric matrix, corresponding rows and columns must be identical. That means first row elements are identical to first column elements. Here first row elements are what? 1, 4, 3. But here first column elements are not 1, 4, 3. So this is not at all symmetric matrix. So this is also wrong answer. So what is the left? Second option. So this is the correct answer. Over. Okay. Next. If the matrix 2 by 2 matrix 2, 3, 5 minus 1 is equal to A plus B, where A is a symmetric matrix, B is a skew symmetric matrix, then what is B? That means from this question you have to understand A is the symmetric part of the given matrix, B is the skew symmetric part of the given matrix. Suppose if you take given matrix is capital P, if the given matrix is capital P, then capital A is a symmetric part, means capital A is equal to half into P plus P dash. Okay, capital B becomes what? Half into P minus P dash. So that means what you have to calculate? Half into given matrix minus it's a transpose. Okay, so as it is skew symmetric, diagonal elements must be equal to what? 0. So don't think about diagonal elements. So think about these two elements. And if this element is alpha, this element must be what? Minus alpha. Correct? So that means you need to calculate only this second element. Over. Okay. So what do you get? Second element. Okay. So this is P. Then what do you get? P dash. So P dash, what do you get? 2, 5. Next to 3 minus 1. Next P minus P dash. P minus P dash into half. So this element minus this element. Only we are calculating this element. We are calculating only this element. Okay. So P minus P dash nally. This position element, what do you get? 3 minus 5 minus 2. Okay. That is the element in P minus P dash. But extra we have to multiply with what? 1 by 2. So 1 by 2 into minus 2, what do you get? Minus 1. As this position is minus 1, this position must be what? Plus 1. Over. Okay. So look at next set of problems. So these problems are conceptual problems. So based upon symmetric and skew symmetric properties of symmetric and skew symmetric. Okay. So first look at this board. So this table, sorry. If A and B both are symmetric or both are skew symmetric. If A and B both are symmetric or both are skew symmetric, then AB minus BA skew symmetric and AB plus BA symmetric. Okay. Next, if one matrix is symmetric, another matrix is skew symmetric, then these two position becomes ulta. That is minus AB minus BA, minus becomes symmetric, plus becomes skew symmetric. That is AB minus BA becomes symmetric, AB plus BA becomes skew symmetric. Okay. So remember like this now. Symmetric like a plus, okay, and skew symmetric like a minus. Plus into plus, plus, minus into minus, plus. Okay, so that means if both are symmetric or both are skew symmetric, AB minus BA skew symmetric, AB plus BA symmetric. And one is symmetric, another one is skew symmetric. Plus into minus, minus. So we have to change. So that means AB minus BA becomes symmetric and AB plus BA becomes skew symmetric. Okay. Now here the question is, first question, if P and Q both are symmetric matrices, so plus, then PQ minus QP is, so both are symmetric, then minus is what? Skew symmetric. That means PQ minus QP matrix becomes what? Skew symmetric. Skew symmetric. Okay? Next, this is also conceptual question. See here, if A is a both symmetric and skew symmetric, then what is A? Remember, zero matrix or void matrix or null matrix. So that is the only matrix which is both symmetric and skew symmetric. So for this question, his answer is what? Zero matrix. What is the answer? Zero matrix. Next, third question. If A is a symmetric matrix, then A power n is what kind of matrix? Where n is a natural number. So if A is a symmetric matrix, then A square, A cube, A power 4, A power how, whatever you take natural number. So that is also what? Symmetric matrix. In particular, A inverse is also, if it is exist, that is also symmetric matrix. Okay. Next, if A is a skew symmetric matrix, if A is a skew symmetric matrix, then what is A power 2n matrix? What is A power 2n minus 1 matrix? So 2n is even number or odd number? Even number. So minus 1 whole power even number. Plus 1 you will get or minus 1 you will get? Plus 1. So that means here you are getting plus. That means answer is what? Symmetric. That means skew symmetric power even number. Skew symmetric power even number is always symmetric matrix. Whereas skew symmetric power odd number is skew symmetric. Skew symmetric power, any even power you take, if A is a skew symmetric, A power any even power is symmetric. A power any odd power is skew symmetric. Okay. For example, if A is a skew symmetric matrix, A square, A power 4, A power 2020, these are all what? Symmetric matrices. So if A is a skew symmetric matrix, then A cube, A power 5, A power 2021, A power 2019, Ivella matrices, what kind of matrices? Skew symmetric matrices. Okay. So look at the next conceptual question. If B is equal to sigma R is equal to 1 to 2020 AR power 2R minus 1, then determinant of B, where AR is a skew symmetric matrix of order 3 by 3 and R is running from 1, 2, 3 and so on 2020. Okay. Then what is determinant of B? So they have not given anything about data of A. So how we can calculate that B? Just it is a conceptual question. So what is the concept behind this? If A is a skew symmetric, if A is a skew symmetric of odd order, then its determinant is 0. Its determinant is 0. Okay. If A is a skew symmetric matrix of even order, then determinant of that matrix is some perfect square. So here the point you have to remember which point. If A is a skew symmetric matrix of odd order, then its determinant is 0. Okay. So first write B. So expand the sigma. Then what do you get? If you put R value 1, what do you get? A1. If you put R value 2, what do you get? A2 cube. Next what do you get? A3 power 5 and so on. A2020. No need to calculate the power, okay? But you calculate, so 4039 you will get. Okay? So A1, A2 cube, A3 power 5, A2020 whole power 4039. So just now discussed. So if A is a skew symmetric matrix, if it's odd power, okay? If A power any odd number is also skew symmetric. Okay. As A1 is a skew symmetric, it is basically skew symmetric. As A2 is a skew symmetric, A2 cube is also skew symmetric. As A3 is a skew symmetric, A3 power 5 also skew symmetric. That means this is also skew symmetric because the power is what? Odd. And some of the skew symmetric matrices are also skew symmetric. Okay. So here each matrix, each term here observed, each matrix is a skew symmetric. then sum of all these skew symmetric matrices is also skew symmetric. That means this whole sum is equal to what? B. That means B is a skew symmetric matrix. And what is the order of the B? 3 by 3 only, na? What is the order of B? 3 by 3. So that means B is a skew symmetric of odd order. So therefore its determinant must be equal to what? 0. So look at the next set of problems. Okay. The constant term in the expansion of this determinant. So if you expand this determinant, what you will get? You will get some polynomial or some expression in x. Correct? In that expression, what we have to find? Constant term. Okay. So whenever if you want to find a constant term in a polynomial, just you put x is equal to 0 in that polynomial to get constant term. For example, suppose f of x is equal to 2x square plus 3x plus 5 is there. What is the constant term in this polynomial? 5. Okay. So if you want to get this constant term of 5, so it is the same as f of 0. You know what is f of 0 value? 5 only. If you put x value 0, what you are getting f of x value? 5, which is same as constant term in f of x. So to get constant term in a polynomial, just you put x is equal to 0. So here don't try to expand this determinant, just you put x is equal to 0. You put x is equal to 0. And what you will get if you put x value zeros? If you put x value zeros, what you will get? Det of 1. So 3 into 0, 0, 0 plus 1, 1. Next to minus 1, 2. Here 1, 2, 1. Next to minus 2, 1, minus 1. So just expand this determinant. Whatever you are getting a number, that number is the constant term in the expansion of this determinant over. Okay. So you can able to expand this determinant. Okay. Next, look at the next problem. The value of this determinant. So this can be done in two different ways. I am explaining only short method. Okay. So short method is you put x value 0. If you put x value 0. If you put x value 0, 5 power 0 how much? 1. 5 power minus 0, nothing but 5 power 0, 1. 1 minus 1, 0. That means this element is also 0. This element is also 0. That means all the elements in the second column are zeros. So then using the property of determinant, then the value of the determinant becomes what? 0. So the value of this determinant is what? 0. Shortcut is what? Put x is equal to 0. So suppose if you want to method, you do one thing. You apply the operation C1 goes to C1 minus C2. Column 1 goes to column 1 minus column 2. And use a plus b whole square minus a minus b whole square is 4ab. Okay. If you apply that operation, first column elements becomes 4, 4, 4. If you apply the operation C1 goes to C1 minus C2 and use a plus b whole square is equal to a plus b whole square minus a minus b whole square is equal to 4ab, then the first column elements becomes 4, 4, 4. If you take 4 common, first column elements are 1, 1, 1. Third column elements are also 1, 1, 1. So C1, C3 are identical. Hence the value of the determinant is 0. But short method is put x is equal to 0. You will get value of the determinant is 0. Next, here is it possible to put x value 0? Log x, is it defined for x is equal to 0? No. So here it is not possible. So here we have to do method. Okay. So here given what? Where x, y, z are real numbers and they are not equal and they are positive but they are not equal to 1. So you can't put x value, y value, z value 1, 1, 1 also. Okay. So then how to do this problem? So just I am giving the hint. You apply the operation R2 goes to R2 minus R1 and R3 goes to R3 minus R1. Okay. So if you apply this operation, then this element becomes what? A log 2x minus log x. Log 2x minus log x can also be written as log of 2x by x. Using log a minus log b is equal to log of a by b. So log 2x minus log x value becomes what? Log of 2x by x. Nothing but log 2. Similarly, here also what you will get? After applying R2 minus R1, log 2. Here also what you will get? Log 2. Next, if you apply R3 minus R1 operation, this element becomes log 3. This element becomes log 3. This element also becomes log 3. If you take log 2 common in second row and log 3 common in third row, automatically R2 and R3 are identical. Then the value of the determinant becomes what? 0. Okay. So with this, I am going to close this session. Hope you understand all these problems. So once you practice these model problems in your materials, then definitely you will get 7 marks. Definitely 7 marks in your pocket only. 7 marks, minimum 7 marks in your pocket. Already differentiation 6 marks. This is the minimum 7. So 7 plus 6, 13. Minimum 13 marks are there in your pocket. So if you watch these videos, differentiation video and matrices and determinants video. If you like this video, please share this video to your friends and ask them subscribe my channel to get more number of videos. Thank you.